Find the derivative of xy to the 6 minus x squared y plus 5x equals 3. We have here an implicit equation. It's an equation involving x and y, but it's not solved for y in terms of x. Rather, they're related to each other through this equation. It's not possible to solve for y in terms of x, so we will have to take the derivative implicitly. This is done by taking the derivative of both sides with respect to x, indicated by a prime on both sides. The first term is the product rule, x times y to the 6. The derivative of the first, derivative of x, is a 1 times the second left alone, y to the 6, plus the first left alone, x, times the derivative of the second, which is a power rule. Bring down the 6, subtract 1 from the power, and then we multiply by the derivative of the inside, which will give us a y prime. Every time we take the derivative of a y term, we will have a y prime to complete the chain rule. The second term is the product rule, negative x squared times y. The derivative of the first is a negative 2x times the second left alone, plus the first left alone, negative x squared, times the derivative of the second. Derivative of y is 1, but then multiplied by y prime to complete the chain rule. Once again, we had a derivative of a y term. The third term, constant times x, the derivative will be the constant. That will give us a 5. And then equals 2 on the right side, we have the derivative of 3, which is a 0. We want to solve for y prime here. There's two terms that have a y prime in them, but before we isolate those, let's write this in a little bit simpler form. The first term, the 1's implied, so we can write it as y to the 6. The second term, we can move the 6 to the front, so we have 6x, y to the 5, y prime. Third term, we can leave as is. The fourth term, the 1 is implied, minus x squared, y prime. And the fifth term, the 5, we can just leave alone. Here are two terms that have y prime in them, here and here. We want to isolate these on one side. Let's leave them on the left, and we will move everything else to the right. So I will keep 6x, y to the 5th, y prime, minus x squared, y prime on the left. And the other three will move to the right. I'm going to start by moving the negative 2xy because it will become positive 2xy when we move it over. We add it to the other side. The y to the 6 will subtract over, and the 5 we will subtract over. We can now factor the y prime out of the left side. And we can solve for y prime by dividing both sides by what's in the parentheses. That will give us 2xy minus y to the 6 minus 5 all over 6x y to the 5th minus x squared. There's our derivative y prime. Now it is possible to take one more step to simplify this a little bit more. Currently this has 3 negative terms in it and only 2 positive terms. It's a lot of times customary to have more positive terms than negative terms. And what we can do is factor a negative out of the numerator and denominator. If we factor a negative out of the numerator, that will make the 2xy become a negative, so we won't write it first. The y to the 6 will become positive, so I will write that one first. Then the negative 2xy, and then the positive 5 over, and factoring a negative out of the denominator will make the x squared term become positive, and the 6x y to the 5th to become negative. And the negatives we just factored out can cancel with each other. We have y to the 6 minus 2xy plus 5 divided by x squared minus 6x y to the 5th. And there's another way to write the result. Either version is a valid answer. This second version has fewer negative signs. It has only 2 negative signs now, and so it's customary to write it this way, but either one is valid, and there's the result for y prime.